So the software that will be I'll be introducing to you is EES software. It is engineering equation solver software. This software is the demo version is available online. I'll guide you how to download it, and let me give you a brief overview of the software. Basically, this software is an equation solver. Like you have mathematical equations and you want to solve them. One way is that you solve those equations on your notebooks by the principle that you already know of basic mathematics. Similarly, in many of the problems that you'll encounter, you have equations to solve. Uh, you have equations to solve the uh, pressure equation where pressure is equals to rho gh. Pressure is given, rho value is given, g is given. You have to calculate height, so you plug in the values and find out the h value. This software essentially helps you to calculate those values without using your calculator. So you'll write your equations, you'll plug in your values, and you'll find out the unknown. So the basic software is basically solving the unknown using equations. Uh, One thing you will learn is how to write equations in this software. The importance of this software with regards to thermodynamics is that most of the thermodynamic data, the tables that are there at the end of your book, those tables are already incorporated in this software. So you can essentially extract the data out of tables to solve your problem. You will not be able to get much of it right now unless and until you look into the examples of chapter 3, which probably we'll see this week sometime. If the time permits, we'll start today, but if not, then the coming 2 hour class you'll be able to understand how to use the tables. So this software would also help you to extract the data automatically out of the table. You ask him to calculate a certain value, find out a certain value from the table in a certain manner, it would automatically find out the value for you. Instead of you looking up in the table, it would facilitate you. So what is the purpose of the software? Let's hold on to that and see the purpose of the software in few minutes time. I'll guide you how to download the software first. So this is the link given. I'll share the slides. If you click on this link, you'll be able to open up the web page, which would ask you certain information. Like the information shown to you, you have to provide these basic details. This is a demo version, as it says, it's a demo version for Windows. So those who are using Windows, they'll be able to download it using this link given. You'll have to plug in this information, your name, your email address, in company or affiliation. You could write us, city, Rawalpindi, postal code, country, phone number, educational purpose. And if you click on the that I am not a robot and submit this form, you'll window that will open up. This is basically the demo version. If you click over here where it is written click here, you will be essentially able to download the software. It's a very easy to download software. Once you download the software, you will have basically uh, once you click here and download this software, you'll be able to run the software. Once you open up the software, EES software, this window would open up, which says Engineering Equation Solver. It's a demonstration version. So there are certain limitations of this demonstration version. One of the limitation is that you will not be able to save your equations or program that you will develop. Neither will you be able to print it. So what I do is that I normally take the screenshots to capture the data with me. So far, is it clear? The downloading and installing?
Yes, sir.
All right. It's simple enough. All right. So once you open up, this window would open up. Once you press continue, you'll have this window. Here it is written that you have this as the equation window, and there are some instructions given about the demonstration version. You don't need to do anything. You just need to click over here, file. When you click file, there would be several options. You click on the button which says new. When you press on the button new, you'll have this new window open to you, and this would be your equation window. This is the window where you'll write your equations. So far, is it clear, or is there any doubt? So
No,
far,
sir.
is all right, clear. So let's move on and look at an example. First, let's see how we can solve the problem on the notebook or without the software, and let's see what is the advantage of the software. So let's say we have this common physics example which says that a 3 kg rock is thrown upward with a force of 200 newtons at a location where the local gravity is this. Determine the acceleration of rock in meters per second square. So let's say if I have this rock with me and I have applied a force of 200 newtons onto this rock. All right, and now I want to determine the acceleration of this rock as a force of 200 newtons has been applied to it. So this is your force, or W up is basically 200 newtons. This is given to you. What would be the downward force acting?
Weight of
mg.
3
Yes,
Sir, weight
mg
of
3
the.
W equals W down is basically nothing but mass multiplied by G. All right, this is weight down, and you know the net force would be what? Net force would be W up minus W down. This would be the net force acting on it, and you know that net force is equivalent to mass into acceleration. So net force is known to you, mass is known to you, and you can find out the acceleration. Clear? Mg is what? 3 kgs multiplied by 9.79. Is this clear?
Yes, sir.
Yes,
All
sir.
right. So you can do it simply on your notebook. If I have to solve this on the equation solver, what I have to do is that I'll show you the script that I have written. This is the script that I have written. It says first I have defined the weight W is equals to mg. This is the weight that I have defined. W is, I have used any symbol W for the weight. Mass is defined by the symbol M, and G is defined by the symbol G. Now the software doesn't know what is the value of mass and gravity. So next what I do is that I define the value of mass equals to 3, and in the square brackets I write down the units, which is kg. And similarly, I define the value of g, which is 9.79, and I define the units to be meter per second square in the square brackets. These are basically constants. So for constants, you can define the units in square brackets. But for an equation, this is an equation, you cannot define the units in this form, square bracket. So far, is it clear?
Yes, sir.
All right. Now I say that the force downward acting is equivalent to W. So this W is actually the force acting downwards. Force upward acting is basically force. This F underscore down is my representation of downward force. You can represent it by anything, FD, F1, Fx, whatever you want to write, you can use the symbol. I have used the symbol F underscore down for the downward force. Similarly, for F upwards, I have written that it is equivalent to 200, and I have defined the units in the square brackets to be newtons. And what is the net force? Now, net force, again, this is a symbol that I have given to net force. I can always write it with Fn or F net or F uh, resultant, whatever I want to write, I can write the name. And now I say that F net equals to F up, this symbol, minus F down, which is this. Is it clear so far? And then I write another equation which says that F net is equivalent to mass multiplied by acceleration. Now in this equation, F net he can calculate, mass he can calculate, and A is the only unknown which can be calculated using this equation. Is this clear so far?
यस सर। सर इक्वेशंस में आगे यूनिट्स नहीं लिखेंगे?
इक्वेशंस में आगे आप यूनिट्स नहीं लिखेंगे, उसमें यूनिट्स किसी और तरीके से एंटर होते हैं. यू डोंट राइट यूनिट्स इन द इक्वेशंस. Wherever you are writing constants, you can write the constants, the units with the constants, but wherever you are writing the units, the equation, you will not write the units with the equation. All right. So now what I do is that I'll go to calculate. Once I calculate, press calculate, there would be several options available to me. I'll select the option solve. This would solve for me that if the mass is 3 kgs, the upward force is 200 newtons, the gravity value is given to me, what is the acceleration? So you can do it numerically on your calculators. You can do it using this equation. So once you press solve, it would solve for you and it would give you all the values. It would give you the acceleration value to be this, downward force is this, net force is this, upward force you have given, gravity you have given, mass you have given. So these values are the values that you gave. These are the calculated values based on whatever information you gave. Clear enough?
Yes, sir.
All right. Now, the important thing is uh, you you can press on this units. If the units are not correct, you can press on this units. This is basically the units he has calculated. They may be incorrect. So these are the units for the equations. You can press on this and re-enter the correct units. The window would pop up and you can write the correct units. So it would rectify the units. The important thing is that this is one calculation. I want to see that if I change mass, if I have various values of mass, how would acceleration change? This is where I have, let's say, 10 or 20 values of mass. I have 10 or 20 values of mass, or 10, 12 or 20, whatever values of mass changing, and I want to see how would the acceleration behave. All right. So this is where this software becomes very handy, that you don't have to do the calculations every time. How do you use this software to see the behavior of one variable with respect to other without doing multiple calculations? This is where this software becomes very handy. Clear? You're getting the purpose of the software now? All right.
Sir, but the bar after f is equal to m indicates that the calculation is finished here, or what
No,
indicates?
it's while I took the screenshot, there was cursor over here. So this is basically a screenshot. It doesn't indicate anything. You can finish your equation over here. This is basically the cursor blinking over here while I'm typing. So I took a screenshot. This is that cursor. All right. This has nothing to do with the
Okay,
program.
sir.
All right. Acha. So let's see how we can see the behavior with respect to change in mass. There's an option over here which says tables. When you press this table, the first option or the second option is of parametric table. You click onto that option, it would it would show all the variables given to you. On the left hand side, there would be a panel where you have all the variables given to you, where you'll have mass, acceleration, W, G, F up. So F up is given, F down, and F net. All the symbols that you have used, they will be given over here in the parametric table. It would ask you to select the variables in which you want to see the behavior. There would be an arrow over here. So you select mass, you highlight mass and press this button. So mass would appear over here. That is your variable that you want to see. Second variable is acceleration. So you press on A and you press this button. So A would appear over here. Now these are the variables in which you want to see the relationship. How the acceleration changes as you change mass. Clear enough? You have defined your variables that you want to study. Is it clear?
Yes, sir.
All right.
Yes.
Moving on, once you define these variables, mass and acceleration, you have selected these variables, it would pop up, the table would be generated. This is a table that is being generated for you. Forget this table one. Assume I already have a table with me when I took the screenshot. So this is the table, which is table 2, which has been generated for you. And once you were at this stage, he would ask you how many values you want or how many runs you want to run. By default, it gives you 10 runs. 10 runs mean it would run it 10 times. That means you can enter the mass values from 1 to 10. This is you can do. You can always increase the run by how you press right click over here and insert or add run option. So you can increase these runs to run 11, 12 and so on and so forth, whatever number you want to. Clear enough so far?
Yes, sir.
All right. Now, mass is what I want to vary, and I want to see how the acceleration. So what I'll do is that I will press over here at this button. I'll press over here. A window would pop up. This sort of window would pop up, which says M, which represents mass, which is column 1. From first row to last row, which is 20 rows. I had increased the rows to 20 previously. And I say that my first value of mass is 1 kg and my last value is 20 kg. And this option over here, there are multiple options. This says that it should last value should be 20 and it should increase linearly. So what it will do is that it will start, and if I press OK over here, if I press this button, what it will do is that it would plug in the values of 1 to 20 linearly. So 1, 2, 3, 4, 5, 6, 7, 8, and so on and so forth. It would go up to 20. I can do this manually also. I can plug in the value. I can select this column, write 1, 2, 3, 4, 5, so on and so forth manually also. But this step basically reduces my time. So I can generate from 1 to 20 the values of masses. Clear enough?
So if there are 16 rows or 15 rows, then it will also automatically give them in decimals.
Then it would increase. So it would divide from 1 to 15. If you have 15 rows, and sorry, if you've given the last value as 20 and you have 15 rows from 1 to 50 or 15 runs, so it would automatically distribute from 1 to 20. It would distribute from 1 to 15. It would distribute the values of 1 to 20 in a linear manner. So you'll have decimal values also. Clear enough?
Yes, sir.
All right. So once I have plugged in the values, the I could go to calculate, and probably the third option is solve table. It would solve the table for me. All right. It would generate all the values for me. But there is one condition. If you see in your program, you have given mass the value of 3 kg. All right. You have given it a fixed value. But in the table, you have varied the value from 1 to 20. So in order for the software to recognize mass as a variable that has values from 1 to 20, what you will have to do is that you will have to select this, highlight this column and right click, and you will use the option of comment. So this will be converted into comment. This M, if I have written M equals to 3 kg, this would convert into comments. How? You will have curly brackets over here, and this would appear in blue color. So that means you have mass as the variable. Clear enough?
So can you repeat it?
Yes. Initially, you had defined mass equals to 3 kg like this. Now, at this stage, the software is recognizing mass to be a constant value of 3 kg. But whenever you are using a table and you are using mass as a variable whose value varies from 1 to 20, you have to software that you now want to consider mass to be a variable. How do you communicate to the software that you want mass to be a variable? You will go to the region where you have defined mass. You will select that line. So what you will do is that you will go to the line where you have defined that constant. This line, you would select this line, highlight it, right click on this location, and there would be several options that would pop up. The first option would be comment, and it would give you curly brackets. So you select that option, you will see that mass would convert into this form. It would appear in blue color and you'll see curly brackets around it. All right. This means that now software would recognize mass as a variable whose values are varying from 1 to 20 defined in the parametric table. Clear enough?
Yes, sir.
Right. So now you see, you see over here, if you look closely, uh, over here, I have defined mass in curly brackets. By right clicking on this and selecting the option of comment, I have defined mass in curly brackets. Now it would recognize mass as a variable. Once I have done that, I'll go to again calculate and I would select the option of solve table. Once I do that, I would see that I would get the values of acceleration for me. All the values of acceleration would be automatically calculated for me. Clear enough?
Yes, sir.
All right.
Yes. Yes.
Now, once I have this table available to me, the only thing I need is to plot it. So what I'll do is that I'll go to again the software main window where it says plots. I click on this plots. It would give me an option of XY plot. I'll select that plot, that window. Once that window open up, I will define my X to be mass, my Y to be acceleration, and I would select the plot option. So it would automatically do is that it would plot for me acceleration versus mass. So I understand that as I am increasing my mass, the acceleration is decreasing sharply and it goes almost to zero as I approach to 20 kgs. So for a mass of 20 kgs, 200 Newton force applied upward would give acceleration to be equivalent to zero. This is a behavior that I have studied just in, let's say, 5 minutes. Otherwise, I'll have to do the calculations all over again for 20 calculations. Then I'll have to plot it and understand the behavior. So this makes my things very quick and fast. Clear enough? Is this clear?
Yes, sir.
Yes, sir.
Yes.
All right. So, all right. So I've already shared the script that I have written over here. This script is also shared for you. So if you want to practice, you can use the script. This is the script given to you. You can use this script, copy paste it in the EES equation window, and you can try to replicate the process to understand how you plug in the equations and run the software to solve it for you. Clear enough? Now, moving on, we have another example which says you have seen these examples. You have solved these examples. We are just looking how EES could help us evaluate the problem. Both a gauge and manometers are attached to a gas tank, and if the reading on the gas tank is 80 kilopascal, determine the distance between the two fluid levels of manometer if mercury is this much density in part A and if water is this much density. So you know if 80 kilopascal is shown over here at this point over here, you would also have pressure of 80 kilopascal. Remember 80 kilopascal. And at this point, you will have the pressure of P atmospheric. What is the difference between the two pressures? It is basically, if I start from this point, point 1, and I come to this level over here, point 2, the pressure is basically equal from 1 to 2. The pressure basically increases rho gh, and rho gh is essentially equivalent to 80 kilopascal. Is this point clear to you? Is the point clear?
Yes.
All right.
Yes, sir.
So you have the gauge pressure is equivalent to rho gh. Now this is given to you. Gravity is known to you. Density of mercury is known to you. The only thing unknown is h. So I'll make h as the subject of the equation, and I'll have this relationship. For mercury, what I have to do, I have to plug in the values of 80 kilopascal divided by the density and acceleration. And remember, if I am converting this into kilonewtons, I have to multiply it by 1000. Clear?
Yes, sir.
By default, a rho gh is what? It is Pascal. If you are equating it to kilopascal, instead of Pascal, you have to multiply it by 1000 over here. Clear enough?
Yes, sir.
All right. So for mercury, it comes out to be 0.60 meters, this height. And when I calculate the same thing for water, it comes out to be 8.16 meters, which is much greater than 0.60. So if I'm interested in how would this height behave, or how would this height change as I change the density of a material. Let's say I'm using mercury or water, or I am varying the density from mercury to water, somewhere in between. Somewhere in between those fluids that have density in between mercury and water, how would the height behave as I change the density from mercury to water? Clear enough? This is my goal. So far, is it clear?
Yes, sir.
So this is my program. Again, I'll show you the program first. What I have done is that I have defined delta P as the gauge pressure. You can write any value for it, any symbol for it. You can write gate pressure, you can write delta P, you can write only P, whatever you want to write. You have written the value of 80, and in the brackets you have defined kilopascal as the units. Similarly, for gravity, you have defined the value and you have given the units. Now, what is rho or density? Density, you have defined rho equals to 1000 kg per meter cube. But if you see, I have placed rho in curly brackets. Why?
So वेरी कर सकते हैं आप उसको कांस्टेंट नहीं है.
Yes, I am using this as a variable now. All right. Then I am writing the simple equation which says that delta P or P gauge is equivalent to rho, which is density, multiplied by G, which is gravity, multiplied by H. Now, P gauge is basically in kilopascal, and this over here is in pascals. So what I do is that I can convert any unit, I multiply it and use an inbuilt function which is convert. This is an inbuilt function which says that you will be converting pascals to kilopascal to keep your equation homogeneous. So I multiply and I write over here convert what? Convert pascals to kilopascals. So this whole rho gh, which is in pascals, would be converted to kilopascals using this function. Clear enough?
सर ये रो का वेरिएबल ये समझ नहीं आया.
रो को वेरिएबल लिया, ये समझ नहीं आया। आप फिलहाल यहाँ पे इसको भूल जाएं। यू कंसिडर दिस एज अ कांस्टेंट नाउ। अब ठीक है फिलहाल।
Yes, sir.
ऑलराइट, नाउ in this equation, in this equation, what should be the units of h?
मीटर से।
It should be meters. I also want the answer in h is in meters. I also want the answer in millimeters, h value in millimeters. So what I do is that I define another variable which is h in millimeters, or you can write h mm, h uh, any other value, h2, whatever, and you say that it is equivalent to h, which is in meters, multiplied by using the function convert it into from meters to millimeters. So this value would be converted into millimeters. Clear enough?
सर ये जो आपने सिर्फ सेकंड लास्ट इक्वेशन लिखी है, मैं आप पूछना चाह रहा हूँ कैसे, मतलब कि प्रोग्राम को कैसे समझ में आएगा कि हमें आंसर जो पास्कल्स में चाहिए, न्यूटन पर मीटर स्क्वायर में नहीं चाहिए?
All right. Once you have defined this unit as delta P, वैसे pascals और न्यूटन पर मीटर स्क्वायर, दिस इज व्हाट यू आर टेलिंग। ऑलराइट, इनमें को फर्क है?
नहीं सर, फर्क तो नहीं है, लेकिन जब आपका आंसर वो आपने कैलकुलेट करेंगे, आंसर लिखा आएगा, लिखा हुआ तो न्यूटन पर मीटर स्क्वायर भी आ सकता है।
आ सकता है, लेकिन आपने यहाँ पे डेल्टा क्या डिफाइन किया है? किलो पास्कल में डिफाइन किया है, और उसी से इक्वेट कर रहे हैं। तो नॉर्मली न्यूटन आपने यहाँ पे कहीं पे यूनिट, सॉफ्टवेयर को आपने कहीं पे न्यूटन डिफाइन किए?
नो सर।
दैट्स व्हाई, otherwise you will get the answer, you may get the answer in kg meter, f is equals to ma, so kg meter per second square, and you'll have meter square also for the, so you can have these units, the basic units. All right, since you have not mentioned any other unit. Clear?
क्लियर सर।
All right. So the bottom line is, once you are writing something in kilopascal on one side of the equation, either you write a rho or density gh divided by 1000. You can write in this way, or you can write in this way, convert Pascal to kilopascal. This essentially means that you are dividing this equation by 1000. All right. Is it clear?
यस सर।
All right. Moving on. Now, the important thing is that I want to create a table of density and h in millimeters, or let's say in meters, and h in millimeters. I want to convert. So what I'll do is that I'll again go to the first thing I'll do is that I'll go to this where it is written tables. I will click the option of parametric table. Once I go to the option of parametric table, he'll ask me for the rows. Let's say I define 20 rows, whatever rows I define. And once I've defined the rows, and he'll ask me for he'll ask me for what? He will ask me, once you open the parametric table, he will ask you,
XY.
he'll give you two windows.
तो
Here
पैरामीटर
you'll have all the variables, G, rho, delta P, and H, mm, and H. So I'll select the variable rho over here. This is my variable, and I'll select H, mm, and H. I have selected these three variables. Now, which variable do I want to vary? For rho, I have already given the value of 1000. I want the software to consider rho as a variable. So in order to do that, I'll place it in curly brackets. Once I place it in curly brackets, software would consider rho as a variable, not as a fixed value. Clear enough? Is this clear?
Yes, sir.
I would not have to do the same process for H or HMM. Why? Because I have not given any values, any fixed value for H or HMM. Clear enough? Once I have done that, I'll plug in the value of density from 1000 to 13600. These are the values that I have plugged in. How I have plugged in? Again, I have placed the starting value as 1000, last value as 13600, and I have asked it to increase the values in a linear manner. So it is increasing the values in linear manner. Once I have done that and I go to calculate and solve table, it would calculate the HMM, which is the value of H in millimeters, and H, which is the value of H in meters, and I'll have these values with me. Now I can plot HMM against density using the plot tab, and I can also plot the density against HM on secondary y-axis and secondary x-axis using the plot function. Clear enough?
Yes, sir.
All right.
सर सर ये आपने ग्राफ की जब ग्राफ कह रहा हूँ सर, वो जो वैल्यूज डाली हैं तो उसमें लीनियर नहीं लिखा था सर?
लीनियर लिखा था
सर, ये लीनियर वैल्यूज तो नहीं आ रही।
लीनियर वैल्यूज नहीं आ रही, क्या मतलब?
सर मतलब कि 1000 2000 3000 इस तरह नहीं आनी चाहिए सर?
नहीं नहीं, this means that are from 1 to 20 they are equally distributed. All right.
सर आप
What you
भी की थी सर?
13600 minus 1000 divided by 20 or 19, whatever the values, so it would increase by that amount.
सर आपने
Mathematically.
13 पुट इन की थी?
Sorry?
आपने 13600 पुट इन की थी?
The last value should be 13600. This value should be plugged in. You'll specify, like you go over here. You will specify the first value, let's say 1000. You will specify the last value, let's say 13600, and you can choose the option of linear. So it would be increasing the value linearly. Got the point?
Got it, sir.
Clear enough or not?
Clear, sir, clear.
All right. What it'll do is that it will. So if you. Where is it? So if you take 13600 minus 1000 divided by 19, so you'll roughly get 663. So this is the value it is increasing. It is increasing plus 663 in every value, linearly increasing constant values. I hope it is clear. All right, moving on, we'll quickly look at the third example. It says that at a certain location, wind is blowing at 7 meters per second. Determine the mechanical energy per unit mass and the power generation potential of wind turbine with 80 meters dia blades at that location. Also determine the actual electrical power generation, assuming an overall efficiency of 30%. The density of air is 1.25 kg per meter cube. Now, this is the schematic assumptions. So mechanical, the E mechanical is essentially the change in or the kinetic energy, change in kinetic energy. Clear enough? There is no mention of potential energy, no mention of flow work. So the only mechanical energy associated is the kinetic energy per unit mass. Clear enough? Yes, no. Is the point clear or not?
Yes, sir.
All right.
Yes, sir.
Moving on, if this is your specific energy per unit mass, the value comes out to be 0.0245 kg per kilojoules per kg. Now you have to determine the mechanical energy per the power generation Power is what? Energy, which is joules or kilojoules per unit time, which is kilowatts. And if you have energy in kilojoules per kg and you want to convert it into kilojoules per second, you have to multiply it with what? Kg per second, which is essentially mass flow rate. So if you want to calculate the mass flow rate is density multiplied by velocity multiplied by the cross-sectional area. Density is given to you, velocity is given to you. What is not given is basically the area. You can calculate the area by applying the area of the circle, because that's the circular area that would be important. Diameter is given to you. So you can calculate the mass flow rate using density into area into velocity. Now I want to calculate the power, maximum power generated. It is what? It is the maximum energy generated, mechanical energy, which is mass flow rate multiplied by the specific mass, specific energy. So this is your mass flow rate, this is your specific energy, this comes out to be this much kilowatts. Clear enough?
Yes.
Yes. All right. Moving on, the actual power is what? Actual power generation is what? It is basically 30% of what you could generate. So since the efficiency of your wind turbine is 30%, your actual electrical energy would be 30% of the energy that could have been generated, which comes out to be 323 kilowatts. Is it clear? We have looked into similar example if you remember. Yes, no, so that I could move forward.
Yes.
Now, what I want to understand is what is the effect of velocity and diameter on the mass flow rate and the actual power I could generate. This is important to me. How would velocity affect the mass flow rate and how would the diameter affect the mass flow rate and the actual power that is being generated? Because these are the design parameters for me. In order to do that, I have written a program over here. I'll show you the program. This is the program. Now I have kept velocity initially as 7 meters per second, diameter as 80 meters, and I have both defined them as variables. Eta overall is nothing but efficiency. You can give any symbol to it. I have defined it as 0.3. Density I have again defined as rho. You can give anywhere any symbol for it. 1.25. Gravity value is G 9.81 already given to you. Area you can write. Area is equivalent to pi is a inbuilt function which represents pi. So whenever you have to use pi value, you can write 3.142 or use the simple pi. It would automatically understand what you are referring to. Multiplied by d square over 4 would give you the area. So this is the equation for area. M dot, which is mass flow rate. You already know mass flow rate is what? It is density into area multiplied by velocity. You have defined density with rho, area with A and velocity with V. So it would automatically calculate the mass flow rate with you. M dot maximum is basically W dot maximum that you can calculate. It is equivalent to what? It is mass flow rate multiplied by, which is m dot multiplied by E mechanical, which is nothing but V square over 2. So you have multiplied by V square over 2. Now this mass flow rate multiplied by V square over 2 is essentially joules per second, or in other words it is meter square per second square. If you want to convert it into kilojoules, I have used the function of convert and I have converted meter square second square into kilojoules per kg. Clear enough?
Yes, sir.
All right. And then I have calculated W dot electrical, which is the electrical energy or W actual that you get. W dot actual It is nothing but efficiency multiplied by the maximum work that you can get or maximum power you can get. So I've written all the equations with me. Now what I'll do is that I'll again go to the parametric table. I'll define from all the variables that I have, let's say V, D, eta, rho, G, A, and M dot, and W dot max, and W dot electrical. I'll select velocity D, M dot, and W dot electrical as my variables. Once I do that, I'll have a table in front of me. This is the table that I'll get. I'll select D to plug in the values of diameter, various values of diameter, and then I'll select V from over here and I'll plug in the values of velocity V column 2 from 1 to 24. I have started the value at 5 and here I have used increment. So it is giving me an increment of 5. So it would start with 5 plus 5 over here plus 5 over here 15 plus 5. And here I have written a repeat pattern after every 4 rows. So this is the pattern that I've developed, and then it would again start 5 plus 5 10 plus 5 15 plus 5 20, and it would repeat the pattern. So this is I've used for column V. Now I go to the calculate tab and I select solve table. This would solve the table for me and I will have the mass flow rate values calculated using these tables, and similarly the W electrical calculated for me. I could again go to plot and I could selectively plot for D equals to 20. I could plot this. For V on the x-axis, I can plot the W electrical. So what I have done is that I have chosen my y-axis as W electrical, my x-axis as V, and I have selectively plotted one by one 20, 40, 60, 80, 100 and 120 meters dia. I have selectively plotted. You can plot and then you can plot on top of plot using a command in the plot tab. This is the basics of this EES software. Since I've quickly gone through a few examples, the script of those examples would be available to you just to make you understand how these software works. You will recognize the importance of the software more when you'll move on towards the tables, property tables. In the upcoming class on, I guess, Wednesday, we'll be looking into property tables and we'll go through first how to find out the values manually using the tables, and we'll solve some problems using tables, hard table copies, and then we'll try to solve the same problem using the EES software.